yes Sharbi. Tell me.
بالبريفيس مثلا بيقولوا لنا انه تنجيب الكومبوننتس about مثلا point A.
Components of what? Moment, you mean?
لا بس بيكتبوا components of A يعني مثلا بالبريفيس اول بريفيس نزلتيه.
No, no, reaction component, you mean. You don't have this. I told you, you don't have everything,
اه
okay? You don't, whenever
اوكي.
you see calculate reactions at a certain point, you don't have it. Whenever you see we want to reduce the resultant of forces to one resultant force, you don't have it. Okay?
اه ثانك يو.
Welcome. Other questions? Okay. Do you want, were you able to watch the videos? Is there anything specific that you want me to go over? Please, guys, watch the videos. When I tell you watch, for example, these videos, watch them to prepare your questions. Okay? All videos are,
دكتور
yes? Yes, tell me.
الشابتر 4 كله included in the exam.
chapter 4 كان لحديت الكابل مومنت
الشابتر 4 كله included.
نو لحديت الكابل مومنت بس اذا كثير رجع تاخر الاكزام
اوكي
we might change. Okay? So
معقول
please you
يصير next
don't
Saturday الإكزام؟
don't stick مبدئيا الاكزام للكابل. اوكي بس هلا the exam is postponed and we don't know until which time يعني we cannot stop here, we need to proceed with the material. Okay, that's why I told you to go over the remaining videos of chapter 4 to tackle them. Okay.
دكتور معقول يكون هيدا الساتردي، يعني وقت إذا فتنا ماندي على الجامعة يكون ساتردي دغري؟
معقول yes. إذا فتنا Monday معقول يكون Saturday أو during class time. هلا بنشوف. أوكي بنشوف حسب أي متى بنفوت we decide. بس until now nothing is clear, so please هلا أنا I will still answer whatever you want على الإكزام بس don't stop بالmaterial of the exam. يعني I already asked you to watch remaining videos of chapter 4 because we need to proceed with the material. Okay. رح أفتح review problems of chapter 4.
بالريفيو بروبلمز تبع تشابتر 4 مش بس عنا اول اثنين واخر واحده.
مبلا اوكي. حدا عنده question على اول اثنين واخر واحدة بالشابتر 4؟ Any question on these problems, guys? Anything that is not clear بالexplanation or بالcourse material? حدا بعد عنده مشكلة بالdifference how to get the moment of a force about a point or force about an axis, between the difference between moment component or moment vector? All of these ideas are clear now.
دكتور شو الفرق بين moment about an axis و moment about a point؟
Okay, whenever they, example here in this problem, if they tell you, let me share
دكتور
this.
ما في
Yeah,
سكرين.
yeah, I will share the screen. Yeah, one second. Do you see the screen now? Okay.
Yes.
For example here, okay, I can ask you, they told you to find the resultant moment of the two forces about point O. So what is the equation to start from? The resultant moment about O is equal, since you have two forces here, you need to add their moments about O. So it's equal to the moment of FA about O plus the moment of FB about O. Okay? Now, how to get the moment of a force about a point? we do the cross product, okay? To start with FA, or it's FC, I called it FC, FC, okay? If you look at FC, you can detect 2 points. FC is passing by A, and FC is passing also by C. So when you say the moment is R vectorial F, okay, you know that your position vector R should start from the point for which you are doing the moment about, which is O, and should end on any point on the line of the force. So, or you can take, for example, OA for force FC, but also C is on the line of action of FC. So, or you take R is OA, or sorry, or you take R is OC. Both are right. Okay? Now, which one is easier? It is easier to take OA or to take OC?
OA.
OA.
OA. Since OA is easier as calculation, I will take OA. Okay? So I will do OA vectorial FC. And because you have, what do you know about FC? You know its magnitude. You know the coordinates of 2 points, which are A and C. So FC is passing by A and C. So I will use the unit vector method to define this vector. It's the magnitude, which is 420, times unit vector of AC. Okay? And I do the vectorial product. When you do the vectorial or cross product, you get a vector, 3 components, I, J, K. Okay? I component will represent what actually? What is the I component that you get?
Moment about X.
Exactly. It's the moment about x-axis passing by point O. And J component is the moment of this force FC about y-axis passing by O. And finally, K component will represent moment about z-axis passing by O. Okay? You will repeat the same procedure to get the moment of FB about O. Okay? Here also, for this vector, you have 2 approach. You can take or OA vectorial FB, but also you have the option also to take what is the second possibility? OA vectorial FB or
OB.
what? Yes, or OB vectorial FB. Both are right because A and B are on the line of action of force FB. Okay? And now, if you want, if you have considered OA, and of course OA is easier than, here OA and OB are both easy because B is also on y-axis. So it has only one coordinate. But can you tell me what is the advantage of taking OA here? What is the advantage of taking OA, not OB?
We already took it for force FC.
Yes, very good. We have already considered this vector, so we can take it into factor. Okay? We can take it into factor because look, if you write, you know, from when we did the revision of vectors operation, we said that if I do OA vectorial a certain force, which is FC, plus OA vectorial FB, I can take OA in factor. Okay? If I take OA in factor, what do I get? So this will simplify my work. Instead of doing 2 vectorial product, I do 1. So I do OA vectorial summation of FC and FB. So FC plus FB. Okay? I can do here expansion if you want, because OA is easy, no need for the matrix, because OA is only along K. Or if you want to use the matrix, it's also right. For both cases, you will get a vector having ijk component. And as we mentioned, the component in I will represent the moment about x-axis passing by O, etc. Okay, I will add a question now to this problem, and I will tell you to find the moment of vector FC, okay, about axis OC. If this is the question, okay, what should I do now if I want to get the moment vector of FC about axis OC?
أول شيء we take a point on OC و point on F
Okay.
ونعمل فيكتوريال بين مثلا OA و FC.
Okay. So I have several methods. I can use the triple scalar product, and I can decompose it into parts. يعني into already, for example, in this case, you have already done question A. In question A, you have the moment of FC about O. You already did the calculation. So you have the advantage of saying, since I already calculated the cross product, no need to do the triple scalar product, because by definition, okay, if I have the moment about O and I want to get the moment component of this force along OC, what should I do now? When I ask you to get the moment about an axis, what do? You say, I take first any point on the axis. I can take O, I can take C, okay? Let us say we considered O. If you take O, you say first I get the moment about O. What is the moment about O? As we said, OA vectorial, the force, okay? So the cross product that you already did before, no need to repeat it. You already have the result. And now to project this moment on OC, what do?
Dot product the
Yes.
unit vector.
Very good. Dot product the unit vector of OC. Okay? This will give you what? It will give you a number or a vector. OA vectorial FC dot UOC. How you calculate?
A vector.
No, not a vector. This is, look, dot product will always give you a number. What is this number? This number is x component of the moment. And if you have the moment vector, let us do it here if you want. Let's say this is your FC, okay? This is the expression of your force. This is FC, and they calculated the moment. Here they didn't take OA in factors, they did separate calculations. But at the end, they did the summation, okay? So in case you take only OA vectorial FC, let us do it together. If you want to have what is a moment of FC about O, you just have to do OA vectorial FC, okay? You put plus, minus, plus. And then first, along plus I, what do you have? You say, I will, if I drop this column and this line, I have these four numbers. So I just have 0 times minus 360 minus 6 times minus 180. So it's a plus 6 times 180. Okay? Now, plus minus j times. Now, if I change the color, when I drop these two, what do I get? 0 times a number, which is 0, minus 6 times 120, which is 720, and plus 720J. Okay. And finally, along K, it's 0 minus 0, 0. And here you have, if we consider, let's say, 200, 1,200 minus 120. So it's 1,080. This is 1,080 along I. Okay. So these components represent, as we said, this is the moment of FC about x-axis. Okay, this is MC about x, and this is MC about y. Can you tell me why I can expect that this force FC will not have a moment about z-axis? Why force FC will not have a moment about z-axis? Look at the
Because
figure.
it passes by point.
Exactly.
It
Because
passes
it's
by the
passing
axis.
by z-axis, so it cannot produce a moment about it. Okay? So since I already did the calculation in the previous step, I can benefit from this, okay, to say, let me use this method. If I do dot product unit vector of OC, I will directly obtain the projection component of the moment vector. So my moment vector has only x and y, and I want to project it on OC. So I just have to do, to find first unit vector of OC. If you look at the figure, point C has coordinates of 2 in x, minus 3 in y, and 0 in k. Okay? So UOC vector, unit vector of OC, is equal to, so unit vector of OC,
2
yes,
2i
2i minus
minus
3j over
over
radical of 13. Okay, 2i minus 3j over radical of 13. And we know that when we do the dot product, we take x component of the first vector times x component of the second, plus y component of the first times y component of the second. And here, no z components. So here we have already found what is the moment vector. It's 1,080 in I and 720 in J. So the dot product will give us, so this is equal, so dot product is equal to 2 over radical 13, which is the x component of the unit vector, times the x component of the moment, which is 1,080. Okay, and minus 3 over radical 13 times 720. This is a number, okay? This is a number, so we'll get the projection component. It's a number, I calculated with my calculator. Let's say I get a number x. Once I get this number x, if they ask for the moment vector about OC, I do this number x times unit vector of OC. Okay, so I will get then, this is equal to 2x over radical 13 in I. Okay, and minus 3x. So it's just multiplication. Okay, number times vector will give me a vector. Minus 3x over radical 13 of j. And this represents the moment vector of force Fc about axis OC. Okay, now if we didn't perform the calculation of the moment before, it's easier then to use the triple scalar product. What is this triple scalar product? It's a technique using matrix form to calculate OA vectorial FC dot product unit vector of OC. And of course, it will give me also a number. Let us see how to do it. So we put the triple scalar matrix. We said, what is the first vector? Since we need to get the moment about OC, the first vector is the component of unit vector of OC. So in the first row, I will put unit vector of OC in X, and we have calculated it. It's 2 over radical 13. Second component here is the J component of unit vector of OC. So minus 3 over radical
minus 3.
13. And the last component is 0.
ما في
As I
زاد
told you,
component صح؟
نعم، هول الكومبوننت للunit vector
ما
of
في زاد component
ما سمعت.
OC.
Can you repeat please؟
ماشي عم بقول انه ما في زاد
ما في
component.
Z component. هلا إذا بدكم, because you have radical 13 for both terms, you can take it outside and you can remove it from inner side and take it outside. So you can put outside 1 over radical 13 to simplify your calculation. Okay? Now, what is the second row? Now
دكتور
we want to do R vectorial F. Second row is R. Vector R is OA. So we have only Z component equal to 6 meters. So 0, 0, 6. Okay?
دكتور هيدا اي بروبلم؟
أنا زدت الكويستشن هون. I added
ايه
a
بس ما في البروبلم الاكسرسايز.
أول problem بالchapter 4. First
اوكي
problem in
دي
chapter 4, I added a question. Find the moment of FC about axis OC.
اوكي دي ميرسي كتير.
Welcome. So now,
دكتور عندي سؤال.
yes, tell
كيف
me.
فينا نستعمل يونت فيكتور تبع AC؟
لا كيف بدنا نحن we want to find moment about axis OC. كيف بدنا نستعمل unit vector of AC؟ قصدك بأول row you mean؟
Yes.
لا, of course no. In the first row you put the component of the unit vector of the axis you want to find moment about. You want to find moment about axis OC. So you need here UOCX, UOCY, and UOCZ. Okay? انت وين بتعوزي
أنا
الunit
بس يعني
vector of
بالأول.
AC? Look, you should understand what you are
Okay.
doing. Okay? If you want to find moment about axis OC, then you do dot product UOC. And in the triple scalar product, the first row is for unit vector of the line you are projecting on. You are projecting on line OC. You are finding the moment about axis OC. So the first row should be for unit vector of OC. Now unit vector of AC, why you need it? You need it to find the expression of FC vector. Because what is FC vector? It's directed from A towards C. So FC vector, you need here unit vector of AC, is the magnitude of FC, which is 420, times unit vector of AC. Okay? Clear?
Okay, thank you.
And we have already FC here. We have already calculated the vector. So we place here 120 minus 180 and
بس دكتور
yes, yes.
FC is passing by OC، ليه عم نحسبها؟ مش مفروض يكون المومنت تبعها زيرو؟
كيف اف سي؟ اف سي مبلا مي فيري جود، برافو اكيد. كان فينا كل هيدا الشيء ما نعمله. We should get when we calculate.
ايه بنبلش فرد مره باف بي.
نعم
لازم فرد مره كنا نبلش باف بي، ما اف سي بتدق بي او سي، فthere's no moment there. اذا
100%.
بلشنا باف بي كنا هيدا الشغل كله ما عملناه.
نو لحظة شوي. انت اكيد انا عم بعطي example. هلا اعتبر انه هي because it's passing you can directly say that you should have a moment of zero. Okay, it's right, what you are saying is right, but in case you didn't pay attention for this, you should do the calculation and you will get back to the result that it's equal to zero. Okay.
اوكي سوري انا
هلا
ضيعت لأن فكرت انه عم نعملها.
no هلا اذا طلبوا منكم now the resultant moment about OC, ساعتها you can say from the beginning FC is passing by OC, so no need to do the calculation. If I do the calculation I can verify and I will get a result of zero. تعال نجربه. If we put here plus minus plus, okay, we should get zero. You have first. This you can take it, you can keep it outside. 1 over radical 13. Okay. Times first plus 2. If I drop it to شو عندي 0 times minus 360 minus يعني plus 6, so times 6 times 180. Okay. Now minus يعني plus 3 plus 3 times, if I drop these two I get 0 times minus 360 minus 120 times 6. Okay, and if I do the calculation I should obtain here, I should obtain 0. Okay, I should obtain a value of 0, and this is expected. Yani I could have avoided all of these calculations because I can say since FC is passing by axis OC, of course I will get a moment equal to 0. Now, if I want the moment of FB about OC, okay, I will do the same work. Just I will replace what? I will replace only the last row because the first row is for the unit vector of the axis I am projecting on, which is OC. The second row is for R, but R is common for both. It's OA. So I only have to change this. I only have to change the third row. So I just have to put the components of FB, which are, as we can see here, the components of FB are 300J minus 720K. So I have 0, 300, and minus 720. So I repeat, when I do the calculation, I just have to fix these numbers. So first along, when I take I, okay, I have 0 times this minus 300 times 6. So instead of 180, I will put here 300 minus 300 times 6, okay? And then for my second component, okay, I have minus, so it's also plus 3, times I have 0 minus 0, it's 0 here. Okay, so if I have to get the moment of FB about OC, I will just have this. It's minus 2 times 6 times 300 over radical 13. This will directly give me the moment of FB about OC. Okay. Any question on this? And this is a number, guys. This is a number. If they ask you for the moment vector, after you get the number, you say this moment is projected on which line? On OC. So I should multiply this number by unit vector of OC. Okay. Now for problem 2, we want to determine the resultant couple moment of the two couples acting on the pipe assembly. The distance from A to B is 400 millimeter. Express your result as a Cartesian vector. We want to get the moment, the resultant moment couple. We have how many couples here? 2 couples. So when they ask for the resulting moment, resultant, you need to add the moment created by the 2 couples. Then you need to say, I need first to get the moment of the 35 kilonewton, the 35 Newton forces, okay, plus the couple moment created by the 50 Newton forces, okay. Now, of course, moment is a vector. When they ask for a couple moment, it's a vector. I need to express it. I can have I, J, K component. Let us start with 35. Moment of the 35 Newton forces. This force is passing by B, and this force is passing by A. I have 2 approaches to calculate this moment. Or I say, I will take BA. So if I start from B, I can say BA vectorial this force. So, or I do BA vectorial minus 35K. Okay. Or I say, let me go from A to B. If I go from A to B, I will reach this force. So, or I do AB vectorial $35K. Okay. And also here I have a third method, because this couple is parallel to which plane?
YZ.
Very good. Yani the moment is along which axis?
X.
Very good. And because I know that the moment is along X, no need to do the vectorial product. I can say, I just have to find the magnitude and the direction. For the magnitude, I can calculate the perpendicular distance between the 2 forces. What is the perpendicular distance between the two forces? I have the distance D, and I have an angle here of 30. So the perpendicular distance is D cosine
D cosine 30.
D cosine 30. And how to know if so what is the magnitude of my couple? D cosine 30 times 35. But is my couple along plus I or minus I? How can I know? How can I know if it's along plus I or minus I? I do the right hand rule. If I do the right hand rule with my hand, curl your hand in this direction. Okay, your thumb will point towards negative X or positive X?
Negative X.
Negative X. So this is along minus I. Okay, so this is much easier here because the couple is really simple, which is not the case for the second couple. Before we move to the second couple, is it clear how we got the moment of the first one?
دكتور فيك تعيدي تاني مثل؟
Tany method, yes, I will repeat. Okay. these two forces are parallel to YZ plane. يعني if you want, you can put your couple here in this plane. A force up, a force down. Okay? يعني if you draw, you can draw YZ if you want. If you find it easier to draw it in 2D, you can say this is Y axis, this is Z axis, and my forces, one is parallel to plus Z, one is parallel to minus Z. Okay? If I give you, and vector X is pointing out. So if you want to do a 2D presentation, you just put a point here. It's pointing towards us. Okay? If I give you the 2D plane Y and Z, you can say, to find the moment of these forces, what should I do? I need the perpendicular distance between the two, okay? Which is this distance here, this one. How can you calculate this distance? You have here a right triangle, and the hypotenuse in this triangle is D. And since the angle between D and the distance you are looking forward is 30, so you can say that this distance is simply D cosine 30. So now you know the distance between the two forces, which is 400 millimeter, which is 0.4 meters times cosine 30. Okay. And you multiply this by the magnitude of your forces. You get the magnitude of the couple. You still need the direction. Look in the figure here, how your couple is rotating. Like this. Okay. So if you curl your right hand, if you do with your right hand, these are your four fingers, okay? You turn them in this direction, and then your thumb will point inward. Try it with your hand. The four fingers should rotate in this way, okay? The thumb will point inward. So it's along negative X. Okay? Any question on this? Okay. Look, the meeting will end. I will open another one.